Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 18, Counting Problems. Okay, classwork opening exercise says you are about to switch out your books from your locker during passing period but forgot the order of your locker combination. You know that there are numbers 3, 16, and 21 in some order. Hopefully it's just the first week of school, right? What is the percent of the locker combinations that start with 3? So we have 1, 2, 3, 4, 5, 6 for our total. And we have 1, 2 combinations that start with 3, which equals 1 over 3, which is equal to 33 and 1/3%. Okay. Example 1. All of the 3-letter passwords that can be formed using letters A and B are as follows. AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB. Okay. What percent of passwords contain at least 2 B's? 1, 2, 3, 4, 5, 6, 7, 8 outcomes. That's our total. And then it says what percent of passwords contain at least 2 B's. That would be 2 B's or more. In other words, 2 B's or 3 B's. Well, here's 2 B's, 1 B, 2 B's, 2 B's, 3 B's. So that's 1, 2, 3, 4 out of the 8 have 2 or more B's, which simplifies to 1 over 2, which equals 50%. Okay. B, what percent of passwords contain no A's? Okay, so for the first thing we're going to do is our total is still 8. And there's an A, 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 there's no A in the all B's, and that's the only one. So 1/8. 1/8 as a decimal is 0.125, which is equal to 12.5 or 12.5% of the passwords contain no A's. Okay, page 2, exercise 1. Try these, pause the video, come back, see how you did. All right, here we go. How many 4-letter passwords can be formed using the letters A and B? Okay, so I brought our list over so I don't have to go. You probably have yours left page, right page, but I have to keep going back. So here it is. How many 4-letter passwords can be formed using the letters A and B? Oh, well, we're not using this anymore. We're now going to 4 letters. So here we go. 4-letter passwords can be formed using the letters A and B. So instead of writing, I'm going to type. All right, so make my cap blocks, and how about 10A? There we go. That's not big enough. 12. All right, there we go. Okay, how many 4-letter passwords can be formed using letters A and B? So I could add A, comma space, A, B, A, B, A, B, A, and BAAA. All right, so that is all A's, the first one, and then 4 of them that had 1 B, and now I have to do 2 B's, so that'd be AABB, and then ABAB, and then ABBA, good band, not, and then BABA, and then BBAA. Okay, so let me just stop there for a moment. These are all A's. Three A's, 3 A's, 3 A's, 3 A's. 2 A's, 2 B's, 2 A's, 2 B's, 2 A's, 2 B's, 2 A's, 2 B's, 2 A's, 2 B's. Baba, Alibaba. The band ABBA can be purchased on Alibaba. All right, anyway, just goofing around. Okay, so then if we continue, now I want 3 B's and 1 A. So that could be A, B, 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 A, B, 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 A, B, and then B, 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 A. Okay, so that is one A and 3 B's. All right. You have to be really careful that you're including all of them. And then continuing on, what else is there? So we've done 3 B's, we've done 3 A's, we've done 2 and 2, we've done all A's. The only thing left is B, 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 B. Okay, and what color have I not used? Red, green, blue, black, purple. All right, so there we go. Those are all of our possible outcomes, and rather one solid here. I'm counting, so I might as well just do this. How many 4-letter passwords can be formed using the letters A and B? And the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And am I missing any? Okay, so I missed one because I knew there was going to be 16 because I know how to calculate that. So let me go in and fix it. I missed BAAB. So in the, let me put it right here. I did not have BAAB. So these get moved over here, and this will get moved there. And so now I have another one that was 2 and 2. So that's 1 and 4 is 5, and 6 is 11, and 4 is 15, and 1 is 16. Okay, so now it says what percent of the 4-letter passwords contain no A's at all? These all have A's until we get to this one. So that's 1/16. And if I get my calculator, and take 1 divided by 16, I get 0.625, which is 6.25%. All right, exactly 1A. Well, there's 3 there, 4 there, 3 there, 3 there, 3 there. These are 2's. Exactly 1 are the ones I underlined in black. That is 4 out of 16, which equals 1 out of 4, which equals 25%. Okay, exactly 2 A's. Those are the ones I underlined in blue. That's 1, 2, 3, 4, 5, 6. 6 out of 16 reduces to 3 out of 8. Well, that'd be like multiplying 0.125 times 3, and that would be 0.375, or 37.5%. Okay, exactly 3 A's. That's 1, 2, 3, 4. 4 out of 16, which is 1 out of 4, which is 25%. 25%. Okay. The next one says 4 A's. Well, there's only one. 1/16 equals, I've already done that here, 0.625, which equals 6.25%. And then finally, F, the same number of A's and B's. Well, if there's 4 total, then they have to be 2 and 2. That's my blue. So that was the same as exactly 2 A's. So that is 6/16, which reduces to 3/8, which equals 0.375, which equals 37.5%. And looking back up here, this would have been 62.5%. This is 0.0625, 1/16. Did I do that up above too? Yes, I did. This should be 0.0625. Okay, example 2 says, in a set of 3-letter passwords, 40% of the passwords contain the letter B and 2 of another letter. So there's at least one B and 2 other letters. So B, 2 others, B, 2 others, no B's. So let me just circle what they're talking about. The letter B and 2 of another letter. So B and 2 of another. No. B and 2 of another. No B's, no B's. B and 2 of another. B and 2 of another. So in other words, just one B. Right here, 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 and here, and here. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right. So in a set of 3-letter passwords, 40% of the passwords contain the letter B and 2 of another letter. Which of the 2 sets below meets this criteria? So I counted out how many passwords have the letter B and 2 of another, then check to see if the quantity equals 40%. So in set 1, let me see, we have CBC, AAB, oh, okay. This isn't worded well. 2 of another letter, meaning 2 of the same. So let me erase these. All right, so it contains the letter B and 2 matching pairs. B and 2 C's. B and 2 A's. B and 2 A's. Here's one B but not 2 of the same. B and 2 C's. B and 2 different letters. B and 2 A's. B and 2 C's. Over here, B, these are different. B and 2 E's. B and 2 E's. B and 2 C's. B and 2 C's. 3 B's, 3 C's, 3 E's, no B's, no B's. Okay, just checking. So this is 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10. 4 out of 10, which equals 40, or 0.4. Let me write it in decimal form first, which equals 40%. All right. Over here, I have 1, 2, 3, 4, 5, 6. Out of a total 1, 2, 3, 4, 5 times 3, 15. Well, that reduces to 2/5 or 40%. Okay, so 6 over 15 equals 2/5 because 3 will go into 6 twice and 3 will go into 15 5 times. All right. Okay, so to answer this question, both met the criteria. So I just explained this verbally. You can write down your explanation by saying that the number that contained them was 40%. You could say 40% of 15 is 6 and 40% of 10 is 4, so they both are 40%. Okay, exercise 3. Okay, Shayna read the following problem. How many letter arrangements can be formed from the word triangle that have 2 vowels and 2 consonants? Order does not matter. She answered that there are 30 letter arrangements. 20% of the letter arrangements that began with a vowel actually had an English definition. How many letter arrangements that begin with a vowel have an English definition? Okay. So she did all the work for us already. We don't have to go through and try to find all the four-letter words that contain the word triangle, or letters in the word triangle that have two vowels and two consonants. So I, A, and how about L, I, A, R? Liar, liar, pants on fire. That's a four-letter word with two vowels and two consonants. There's one example. She went through and did that, and she said that there were 30 letter arrangements, because I could also write this as R-I-A-L or R-A-I-L, rail. It didn't say there had to be real words, I don't think. But anyway, 20% of the letter arrangements, so that'd be 0.2, that began with a vowel actually had an English definition. How many letter arrangements that began with a vowel have an English definition? Well, she said that there are 20% of the letter arrangements. So that's 20% of the number of letter arrangements. 30 had that criteria. So when I take 0.2 times 30, I get 6. So how many letter arrangements? 6 letter arrangements. Okay. Number 4 says, using 3 different keys on a piano, a songwriter makes the beginning of his melody with 3 notes, C, E, and G. So he plays C, C, E, 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 G, C, G, C, E, and so on and so on and so on. From the list above, what is the percent of melodies with all 3 notes that are different? Okay, so it says from the list above, what is the percent of melodies with all 3 notes that are different? So first I want to know the total. So we're going to put the part over whole. So the part over whole, the whole is the total. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Using 3 different keys on a piano. Makes the beginning of his melody with 3 notes, C, E, and G. There's 21 outcomes, and we want to know what percent has melodies with all 3 notes that are different. So in other words, there's a C, a G, and an E in it. Right here. 2, 3, C, G, E, E, C, G, G, E, C, and that's it. I believe. C's repeat, G's repeat, 3 C's, 2 E's, 2 C's, 3 G's, 2 C's, 2 E's, 2 G's, 2 E's, 2 G's, 2 G's, 2 E's, 3 E's, 2 C's. So that's it. 1, 2, 3, 4, 5, 6. 6 out of 21. 3 will go into 6 twice. 3 will go into 21 7 times. 2/7 is approximately 0.2857, or 28.57%. Okay, from the list above, what is the percent of melodies that have 3 of the same notes? 3 E's, 3 G's, and 3 C's. So that is 3 out of 21, which is 1 out of 7, which is approximately half of this, which would be 0.14285. So approximately 14.29%, roughly. Okay, because 1/7 is half of 2/7, so I just divided this by 2. Example 3. Look at the 36 points on the coordinate plane with whole number coordinates between 1 and 6. Inclusive, meaning including 1 and 6. So without saying the word inclusive, they could have said between 0 and 7, because 0 is not between 0 and 7, but anyway. A, draw a line through each of the points which have an x-coordinate and a y-coordinate sum of 7. Okay, so I have difficulty drawing straight lines, so I'm going to use this tool. And here we go. Alrighty, so will that work now? Nope, that eliminates it right away. So I've got to do this, pick the thickness, pick that. This isn't going to work. This is in the way. Okay, so here we go. How about I move this down and then it won't be in the way of that. So let's start with red. Look at the 36 points. Draw a line through each of the points that have an x-coordinate and y-coordinate sum of 7. So 5 plus 2 is 7. 4 plus 3. 3 plus 4. 2 plus 5. 1 plus 6. But of course, 6 plus 1 as well. So I need to bring this down here. So there is a line through the points that have a y-coordinate sum of 7. X and y coordinate sum of 7. Okay, next one says draw a line through each of the points which have an x-coordinate, y-coordinate sum of 6. I will do that one in a different color. How about green? And a sum of 6. So that would be 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, and 5 plus 1 is 6. Draw a line through each of the points which have an x and y coordinate sum of 5. So now I'm going to choose blue. And the sum of 5 is 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1. Those are those points that have a sum of 5. Draw a line through the coordinates that have a sum of 4. You're starting to see a pattern here, I hope. 1 plus 3, 2 plus 2, 3 plus 1. And scrolling a little bit. So where are we? Let me show them all first so I don't have to move again. So we just did the first 4. All right, so we are now on a draw line through each point. X and y coordinates sum of 3. Well, that would be 1 plus 2 and 2 plus 1. And then draw a line through each set of points which have an x coordinate, y coordinate sum of 8. Again, I'll change the color. Sum of 8 would be 1 plus 7, not there, 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, and 6 plus 2 is 8. And then a sum of 9, a sum of 10, a sum of 11, and a sum of 12. Okay, I'm going to speed this up now. Hopefully you see what's happening here. That is the point. This is the point 4, 6. So I'm doing sums of 10. 4 plus 6. 4 plus, no, that's a 3. 1, 2, 3. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9. And 6 plus 3 is 9. Okay, orange. Sum of 10, which is 4 plus 6, 5 plus 5, 6 plus 4. Sum of 11 is 5 plus 6 and 6 plus 5. And draw a line through each of the points which has an x coordinate, y coordinate sum of 12. Draw a line through each of the points. So if I drew a line through that, I guess, I don't know. There's only one solution, so let's do that in neon green, and that would be, try that again. Go this way. So there's a line going through the sum of 2. They didn't ask for a sum of 2. We went down to 2. I didn't do that one. Sum of 2 is 1 plus 1. So that sum of 2 that I did not do, is right here. Okay. So there we have it. B says, what percent of the 36 points have coordinates sum 7? Okay, so let me copy this over because we're going to answer questions about this shaded diagram. Let me just fix this and I'll be right with you. Okay, now we can answer these quickly. So it says, what percent of the 36 points have coordinate sum of 7? Well, 7 is 5 plus 2, which is the red line. So there's 1, 2, 3, 4, 5, 6 out of 36, which equals 1 out of 6. And 1 divided by 6 is 1.16 repeating, or 16.7%. Remember, it's an approximation. If I didn't want to approximate, then I'd say 16 2/3%. That's 0.6 repeating. Part C says, write a number expression that could be used to determine the percent of 36 points that have a coordinate sum of 7. Okay, so there are 6 coordinate points where the sum of x coordinate and y coordinate is 7, so I could say 6 over 36 times 100%. Okay, part over whole times 100%. What percent of the 36 points have coordinate sums of 5 or less? So a coordinate sum of 5 or less would be like 4 plus 1, so it's the blue line. This is a sum of 5. This is a sum of 4, 3 plus 1, 2 plus 2. This is a sum of 3, 2 plus 1, and this is a sum of 2. So 5 or less would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. That would be 10 over 16, which equals 5/8, which equals 0.625, or 62.5%. Okay, let me fix that. The total is not 16. I don't know why I said 16, but I was just looking at my work. It's 36, so that changes and all this changes. Let's try that again. 36. 10 out of 36 is 5 out of 18. 5 divided by 18 equals 0.27 repeating. So that'd be 0.27 repeating, which is approximately 27.7 or 8%. If I didn't approximate, it'd be 27 7/9 as a fraction. What percent of the 36 points have coordinate sums of 4 or 10? So the coordinate sums of 4, there's 3 of them, and sum of 10 is 5 plus 5. It is this orange one. 6 plus 4, 5 plus 5, and 4 plus 6. So 3 and 3 is 6 again out of the 36, which equals 1 over 6, which equals 1 divided by 6 is 16 2/3%. And I never finished that. This is 16 2/3% as well, because it's the same fraction. 16 2/3%. Okay, that is the end of lesson 18. Review this lesson summary and go do your problem set.